Today, we are tackling a big one, a force that really shapes everything we know. We're talking about gravity.
So let's just start with a really simple question. Have you ever stopped to think about what is actually keeping your feet planted on the ground while at the same time keeping all the planets just hanging up there in the sky? Well, the answer, of course, is gravity. It's this totally invisible force that's just everywhere. It's constantly pulling all things that have mass or energy toward each other. But, how does that actually work?
To figure that out, we need to dive into what we could call the rules of attraction.
See, the strength of gravity's pull isn't some crazy, complicated mystery. It really just boils down to two super simple things: mass and distance.
Okay, first up, let's talk about mass. It's honestly really straightforward. The more mass something has, think of a gigantic planet like our Earth, the stronger its gravitational pull is going to be. And on the flip side, the less mass it has, the weaker that pull becomes. Simple as that.
And the second rule? Well, that's all about distance. The closer two objects get, the stronger their gravitational grip on each other is. And as they get farther apart, that force gets weaker and weaker. It's exactly why we feel Earth's pull so strongly, but we don't feel Jupiter's, even though Jupiter is absolutely enormous. It's just too far away.
And this is the part that's kind of mind-blowing. As the source material puts it, although every object, including you, exerts a gravitational pull, it is not easy to measure unless one of the objects is really, really big. So yeah, you have your own gravitational pull. You're actually pulling on your phone or your desk right now. But that force is so incredibly tiny compared to the pull of the entire planet beneath your feet that you just can't feel it.
All right, so now that we know the basic rules, let's bring it back home and see how this all plays out in our everyday lives. Let's talk about gravity on Earth.
So when you drop something and watch it fall, you probably think, yep, that's gravity. But it's actually more like a tug of war. There are really two forces at play every single time. On one side of the rope, you've got gravity. It's pulling the object down, trying to make it go faster and faster. But on the other side, pushing back in the opposite direction, is this other force called air resistance. And its whole job is to try and slow that object down.
So, what is air resistance exactly? Well, you can just think of it like friction. It's a force that acts on anything moving through the air, and it always pushes in the opposite direction of that movement.
And this whole tug-of-war thing, it's the reason different objects fall at different speeds. Think about a feather, right? It's super light, but it has a really large surface area. That shape catches a lot of air, which creates a whole bunch of air resistance fighting back against gravity. And that's why it just kind of floats down so slowly.
Now let's take a more, extreme example. A skydiver. They know all about this battle between gravity and air resistance, and they have a secret weapon to help them win. And you guessed it, it's the parachute.
So how does it work? Well, it's pretty genius, actually. First, the skydiver opens the parachute. That one move drastically increases their surface area. And just like with that feather, this massively ramps up the air resistance. It creates the strong upward push that fights gravity, slows them way down, and lets them land safely. It's all about using one force to beat another.
Okay, but gravity is so much bigger than just things falling. It's not just an Earth thing. This is a force that is quite literally everywhere.
So does gravity just make things fall? No, not even close. The very same force that pulls a skydiver back to Earth is also the force that's holding entire worlds together and keeping them from just flying apart into space. And this is where things get really cosmic. That same simple pull is what keeps our Earth and all the other planets locked in their orbits. They're constantly falling around the sun. And on a smaller scale, it's what keeps our moon circling us month after month. Gravity's kind of like the silent, invisible architect of our entire solar system.
So what does all this cosmic stuff have to do with you? Well, that's what brings us to our final section, your gravitational pull.
Because here's the biggest takeaway from all of this. Gravity isn't just something that happens to you. You are an active participant. Because you have mass, you are exerting a gravitational force on everything and everyone around you.
And that leaves us with one last thing to think about. Since your body has mass, you are pulling on the entire planet Earth at this very moment. So the question is, does the Earth pull back? It's just a cool reminder that this fundamental force is a two-way street, connecting you, me, and every single thing in the entire universe.